Okay, right. Okay. Thank you, Neil. Yeah, it's lovely to be able to come and talk to you. Yeah, I reflect on this all the time. I've been spending 30 years as an engineer in the sort of energy and fuel sector, and I've often been accused of talking about what we're talking about today. Today, I'm actually going to be talking about it rather than delivering it. So this presentation is in two parts. The first part is a paper which is hopefully going to be published in the near future, which we've done with Neil as part of the AFN Network. And then the second part is an extension beyond that, some work we're starting to look at within IFEAA and some questions that we're going to look at going forwards. Okay, so first of all, very quickly, why we started this journey. If you look at the inventories, they're fairly flat line, the same every year. And yet when you go and measure the amount of methane in the atmosphere, it's going up extremely rapidly. Something I'll come back to in the future, later in the presentation. And we're seeing about a 17.5 millidegrees per year temperature warming. Doesn't sound a lot, but we've got very little left if we want to hold the 1.5 degrees. Some people tell you you're through it, but the likelihood is we're not going to last to 2050. So the question is that the question that we started was, why is there a difference between what the inventories are saying as sort of bottom-up calculation and what we're observing when you go and measure the methane in the atmosphere? I won't go into this in any great detail because Laura's done a far better job than I can. What I will say is there are, she did mention there are different ways you can use within the IPC of measuring or delivering your inventory. There's a very crude one, which is tier 1, which you tend to find being done in not so wealthy countries, where you very simply look up your average air temperature where you are in the world and read a number off. So the first question is, what's your average temperature? Are you going to take the average winter temperature, the average annual temperature, average summer temperature, average temperature while the slurry is actually in the lagoon, or whatever? And the bottom line is, if we look at that figure, you end up generally with a bigger figure than if you did tier 2. That's quite interesting. I'll show some data in a minute. Tier 2 is this equation that Laura went into. And basically, because I'm a bear of little brain, I reduce that equation to two components. There's the first part, which is this volatile solids and this sort of fundamental conversion amount, which is the potential, the maximum amount you could emit a year per head. And bottom right on there is the bit of our current inventory, or the one last year actually, because that was when this was done. Basically, volatile solids is 5.3, B0 is 0.24, and that means that the maximum potential per head per year is 311 kilos for dairy cows. Interestingly, we report about 38, so we reduced that to 10% of the maximum potential amount. So there's lots of wriggle room between what we currently have and what we might be measuring in how you can modify the way we built the inventory to give accurate results. So fundamentally, we're not saying the inventory is wrong, we're just saying perhaps it's being applied, that there's better ways of applying it. Then there's tier 3, which I don't think anybody currently is using, but lots of people are moving towards or attending towards, which is based on actual data measured and/or models based on actual data measured in situ. Because air temperature is such a dominant figure, something I find really difficult to understand as a sort of thermodynamicist, the reality is cold air will cool something down on the ground, but it won't warm it up. So why air temperature is being used, I don't know. But there you go. We'll come back to that. You pick a load of countries with fairly similar average annual temperatures, you'd expect them to give pretty similar results. They don't. There was a question earlier about why is Denmark so much higher? Interestingly enough, their volatile solids are 2.5 times what most other people are. So maybe they're feeding their cattle something different. So that's what's driving the difference in Denmark. Japan has very high numbers for explainable reasons as well. They basically have a very different historical practice on how they handle manure. They actually ferment it, they always have done, and they have a leaky process. That's why those two are outstanding. But you'd expect the rest of them to give pretty similar results, and they don't. So again, that sort of drove the inquiry. All of them have a B0 pretty similar. So the volatile solids and the B0. So the fundamental maximum number you can have is pretty constant with outliers like Denmark, where for other reasons they quote different numbers. So we started looking internationally, and as we've gone through, people have sort of brought more evidence to us. But this was a brilliant piece of work that was done in Canada. It's basically done in Quebec, because that's where most of the dairy farming is in Canada. It's too cold in lots of the other bits. And they've got 4 different types of lagoons fully instrumented, and they have been there for a number of years. So they've got submerged, so one built into the ground, which is the ground temperature argument, one which is half built into the ground, and one which is above ground. And interestingly enough, they don't give particularly dissimilar results. The other thing I will say about the Canadians is they are past masters, or this particular Canadian researcher, they're past master at totally unfathomable graphs. So let's do a little bit of migration. So the sort of heavier line at the bottom is methane measurement. The line in the middle is air temperature. And then the line at the top is the movement of slurry in and out of the lagoons. So first thing is that they point out there's pretty good correlation with that you get a bloom in methane production when you pump and mix the slurry by adding new slurry or taking slurry out. Air temperature actually, as it drops down to 5 degrees, will then turn to shut the process off. So that's around about November on the graph. And then, but air temperature is rising quite a long way, and you'd expect the process to be kicking off for a long way, and it takes quite a long time. And they were in this thesis went on to ponder whether actually it was the amount of sunlight that was more important, and actually sunlight's a more effective way of heating a structure and transmission through the ground from radiant heat from the sun. That looks better. The key bit here is that they were saying that correlation with the Canadian IPC with slurry returns was very poor, but they could make the numbers work if they were using a practices factor of about 45%. So rather than 10%, 45% of the maximum amount was escaping, which is quite significant. By the way, the maximum amount for Canada is 333 against our 311. So, but they're saying about 50%. So we approached our friends at Abatement, who very kindly gave us data from 2 of their farms, and that's 2 of them. We have solar load data and rain data for both, but I've only put them on the second farm. Not because it weren't interesting on the first farm, but the first farm, basically the sort of dark line shows methane production. The line along the bottom is slurry moving into the lagoon, and then the sort of pale blue line's air temperature. Again, very little correlation with air temperature, and we got an average production of about 145 kilos per head per year. Again, funnily enough, about the 50% of the 311. The second farm, we've added solar load and rain to the plant, and there's really quite good correlation with both of those. Solar load seems to turn it on. If you get a lot of sun, it's a radiant heat load, it heats the structures up. There's about a 2-week delay in that process. You need good sunny weather over 2 weeks, and then you'll start to get more methane. And when it rains, it cools it down. These are covered, so it's not rain entering the slurry, it's rain cooling down the mass by convective heating from below. And the second farm, we're getting 198 kilos per year per head. So somewhere in that 50 to 60% mark seem to be appropriate. We went on to look all around the world at all sorts of different things. 2 big questions. If you cover the slurry pit, does it change the experiment? The evidence wasn't massively conclusive, but it generally pointed to the factor that it didn't, and that's something we're going to set out to prove. The second thing was, were you getting more than the IPC inventory would suggest for your country? All around the world, the answer was yes. And what's more, we also got yes for more on our porcine friends as well, on pigs. But I'll come back to that in my general musings later on. So there is a general mood music within the literature that these numbers are reading low in the inventory. So then, we decided, so what's the effect of this? So what we looked at was the whole EU herd. If we took the difference between now and 2050, using the GWP over that time, attributed based on number of years out from 2050 the gas was done, what would be the impact on global temperature rises of the difference between what's in the inventory and what we're seeing as a basis either from the literature or from the data from Abatement? And the conclusion of that was effectively 1 year's worth of temperature rise of the globe, purely down to the methane from the missing between the inventory and the actual potential of the UK dairy herd. 1 year of global temperature warming, purely down to that. EU, yeah, EU, not the whole global herd, sorry, yes. We then started to think about what's the value of this methane. There are other impacts. There's health impacts. Methane's not particularly great if you breathe it. If you capture it, one farm basically is 24,000 litres diesel equivalent, forecourt prices, that's £38,000. That's quite significant. Then you've got CO2 saving from displacing diesel by using that CO2. If you used it as diesel, that's 64 tonnes. But you've also got to then add in the 43 tonnes from burning the methane. That's a 20-tonne net reduction. Then there's a GWP reduction, which is sort of 1.8 megatons, which is huge. That's just for 100 head of cattle. So we were quite impressed with that. So in conclusion, what we found from the literature, the enteric appeared to be right. A lot of work's been done on that, but the emissions from manure are generally significantly underreported. And we need to do a lot of work on that. So that was the paper that we're working on. Then I sort of stepped back and have looked at general musings. So basically we were looking at, in this, with the UK case, step back and you look at it globally. I'm not going through everything on that slide. Top left, you have the methane measured. It's going up very, very rapidly. As I say, it isn't being shown in the inventories. The graph just to the right of that is an amalgamation of all the global methane inventories from slurry put together. They're all flatline or gently drifting up. It's interesting that that goes to 2020. Since 2020, the big miscreant in that going up was China. So everyone used to sit back and go, we're all right, it's all China. Actually, the Chinese now are reporting a slight downward trend along with everyone else. Everybody on their inventories have got symmetric falling rates. And yet the amount of methane we're seeing in the globe is going up. So, and it's significant. So if you base the global IPC inventory, you should have seen since 1970 a 56 parts per billion rise methane in the atmosphere. Since 1970, actually, we're seeing measured 800 parts per billion inventory rise. So it's significant. So that's led me to the question, to a number of questions. Why are we getting it so wrong? Are we missing something? Is Mother Nature throwing a load of stuff out which we just don't see? Or is it just the Chinese? I don't know. I suggest it isn't, but there you go. Then I sat back and I mentioned pigs earlier, and I know we've got some natural French speakers in the room, so I picked a graph that was done in French. These pictures are all the same. They show cows, they never show pigs, and they never show human beings. It's anthropomorphic, so it's rolled around human activity, but they never actually show the human being as an animal. And that led me to thinking. I went back into the IPC, the UN, and the charters and all the rest of it. They talk about reducing waste. Usually people then point the fingers at sort of landfill, etc. But you've got to bear in mind that the mammalian biomass, human beings make up 36%. And yet, okay, we can't politically say include animals in the human beings in the agriculture bit, because we don't farm humans. Thank you. But we are an animal, and it is significant. So again, went back into the IPC, similar sort of equations for measuring the emissions from human waste that we saw before. We then looked at I then went and looked at the carbon budget and the national atmospheric emissions inventory, and you get a number of around about 4 megatons of CO2 equivalent is put in just as a flat line from time immemorial against human waste. That led me to thinking, so I was digging around, and I sat in on a fantastic presentation done by Northumberland Water, and I do want to protect the water companies. They are, a lot of them, doing some very good things. These guys have put a lot of work in a place called Brand Sands, just outside Sunderland. I think it's Sunderland. I'll get shot if I got that wrong, but never mind. It has a catchment area of 2.6 million people. And they are producing a phenomenal amount of energy. It works out at about 5 kilograms methane per head per year, which roughly, in energy terms, is about 2/3 of a litre of gasoline a month per head. It's a phenomenal amount of money. They've just upgraded as well. So they're saying that that isn't everything it could do. They've upgraded and increased the amount quite considerably. The interesting thing is I thought, let's go back to the agriculture side and use and apply the same agriculture equation to human beings. What do you get? So I found V0, B0 and VS for human beings in Northwest Europe. And that 5 kilos as a maximum could be 27 kilos per head per year. So that's a significant, both in financial value and in terms of emission. Interestingly enough, the B0 is very similar to a pig, which is a bit sort of smashy and nicey as a slip into talking about pigs in the inventory too. I went back into that, did the calculation. The interesting thing is pigs are seen to be such a small problem that it suggests you use a tier 1 calculation rather than a tier 2. But if you do tier 2, it's 35 kilos per head per year, reported for. So again, that 10% number. That led me to start a few red flags. So I did a little bit of a flaky calculation, I'll totally, and this is just thinking it's work in progress. And I said, basically, if we take the humans as an animal, the pigs and the dairy cows, and we said every one of them's 50% discount rather than 90% discount, what do the numbers over 25 years actually look like? Well, the answer is 28 megatons. Now, bear in mind that, and 66% or 18 megatons of that is from human beings. This is in the UK. Bear in mind, we have 4 in the inventory. If you take the 86 GWP number, if you say it's going to be by 2050, that's 94 megatons of impact. So I think it's quite interesting. It's not just the amount per head, because yes, dairy cows are significant compared to people. It's also the number of head. But we are significantly underreporting effectively large chunks of methane going into the atmosphere, which might explain to an extent why it's doing that and not that when you go and measure it in space. So from an IFEAA point of view, we want to develop the argument right the way through from sunlight via the cow. We're talking with collaboration to look at sunlight to milk and energy. Thank you. I'm very nearly there too. But we're going to start looking at pigs, and we're in discussion with doing some measurements similar to ones to get data similar to ones we've done with Benjamin. And we want to start developing this argument about wastewater and see if it's actually genuine or not. The interesting thing is, I sent out a couple of inquiries to a couple of people. I haven't been able to show it today. There's a very interesting study done in Montreal where they actually went around all the streets, round across the top of all the manhole covers. Every single one of those manhole covers is an emitter, low grade, distributed, but every single one is an emitter, which is quite interesting. But that may be next time. Thank you. Yeah, great.
Okay, thanks very much, Andy. So questions for Andy. If we go for questions in the room first before looking online.
None, perfect, I'm off.
One there. So Vicky will bring the mic, and I'll just.
Thanks for an interesting talk. Mine was just because you couldn't see the bigger copy of the black box on the screen, but I was wondering if you could say a bit more about how the system that you measured the methane from, if it was a covered lagoon or
Yes, it was a covered lagoon.
Okay, so the question is about what's the system that was used to measure the methane from the slurry pit?
Yeah, I mean, on the grounds of probably other questions, I'd suggest I hang fire on answering that in detail. I'd say it is a covered lagoon because Chris Pan from Benham will be talking more about their systems later on, but it was from one of their systems that data was coming. Yeah. No, you see that's the interesting thing is when we look, that's one of the questions, that is one of the open questions, but when we've looked at the data across the world and we've done quite a big literature review, the evidence would suggest that putting a cover on doesn't really change the scenario particularly. Further, that there is a suggestion that in many cases it actually reduces the amount of methane that you're producing very slightly. So yeah, I mean, it is a piece of muck that's slung. We're used to muck being slung in this game, but the reality is that the evidence doesn't back that up. But yeah, it is a covered lagoon.
So the cover doesn't make any difference to the amount of methane being produced by the slurry, but of course it can make a big difference the amount of methane being emitted to the atmosphere.
Yes, yeah. The production doesn't change.
Where it opens the atmosphere, the concentration gradients change in the atmosphere.
Oh, now getting to my world. Now that's absolutely fascinating. So the methane coming off the slurry is coming out almost at neutral buoyancy because it's coming out in a mixture with the CO2. If you look at how long a bubble sits on top of a slurry pit or a wastewater facility, it's a long time. It takes a long time for the buoyancy of that gas to actually break the bubble. It went back and did a load of research, actually interestingly enough, from the School of Mines, where they were looking at methane or sour gas coming out of the rock in mines, which is a very similar constitution. It can take up to 25 minutes to rise 1.5 meters. So the gas potentially certainly on a still day, the gas just above the level there is virtually equal constitution to the just below the surface. So yeah, I don't think it really makes any difference at all. And the actual pressure that the bags that are being run at, the covers are being run at, is so low. It's not much different from atmosphere. It's a few percent above atmosphere.
Okay, thank you. Any other questions? Vicky, sorry, Vicky, you've got quite a lot of running backwards and forwards.
Thank you.
Yeah.
So the question is, what about poultry?
Yeah. What about poultry? The simple answer is there are only so many hours in a day, and I haven't got there yet. I'm making my way round. Yeah. I think that there's an issue there, but my understanding is that their guano is very different. It has different chemical composition and behaves differently. So it's something we need to learn about and understand much more about. I would love to come and have a chat with you about that so that we can start to understand the real nature of what's going on there, because I know there's a big problem. I think the reality is also, farming practice has a lot to do with this. The more you concentrate the processes, the more these processes happen. So, bigger farms, less diversity within the farming environment has a big impact too.
I think that from the perspective of the national inventory, it's cattle that's most significant, dairy cattle amongst them that's most significant, and the poultry are rather down the pecking order, we might say. And yeah. Laura's nodding. The poultry is not as significant as cattle. Yeah. So question here. Got lots of hands going up. And then after that, it will be over there.
Hi, Andy. I'm the board of directors. Two. First one
What
is
is it?
when do you think what's
This is
Oh.
you can answer.
So we did an AFN webinar. So there's an hour-long discussion on that work that you can look at on our YouTube channel through the AFN web page. So the question was, when will the report be out? So that presentation in expanded form is available on the net that you can have a look at. And we've submitted a paper to a journal, and we'll have to wait for the refereeing process. So can't say.
Potential.
shows a slide of different fabrics, what countries in how the reported identity values vary quite considerably. Are they all using the same frameworks and therefore counting that in the framework?
Okay, so just to recapitulate for the people online, the graph that showed different reported emissions factors, I think, or emissions levels for the countries, but with relatively similar temperatures. What's going on there?
Yeah. So I suggest actually that we have a chat over coffee, because I think Laura's champing to come in on that one as well. From my point of view, we did go back through every one of those countries and look at how they've constructed their numbers. The framework's the same. The way they apply them can vary and do vary. And it's really interesting how, with time, they ascribe different things to different things, different practices. It's quite interesting, you know, if you go back to the Canadian one, which I went through, they apparently 70% of their dairy farms dug lagoons in a 4-year period. You'd expect several companies to have done really well out of that. Nobody mentioned it in any company returns. And there is no evidence when you look on Google Earth of all these lagoons appearing. But the interesting thing is they then ascribed a different factor to it, so the end number stayed the same. So there's all sorts of things you can do. The reality is, I think, you know, I don't know, I'm not going to second guess the motivation behind it. I'll let the more political people in the room do that. But the reality is, yes, they do use the same framework, but they apply it in their own nationalistic style.
We'll just go online, and then the next question, Vicky, will be over there.
Okay. Yeah, so all I want from here on the course, CSG, is with the methane emissions saved by having a cover on the stores that can be moved to the field when the survey is spread.
Sorry, I didn't catch the question.
Yeah, so the question is, if you capture methane with a cover, won't those savings just be used up when the slurry spread on the land?
Not if you've captured the gas and used it for something else, no, because the material has degraded. There's a maximum potential, so it has degraded. The AD process stops when you spread it on the field. So consequently, no, I think it's a simple answer. I think,
yeah,
I'd be more than happy to catch up with that later if I've misunderstood the question.
I think it was from online. Question there.
Do you think the underestimation of methane that you have mentioned that we were responsible for methane for humans, and I was curious about have you done estimations about management as well? Are we doing the same problem?
Okay, so the question is, with the suggestion that we might be underestimating methane emissions from humans, which is a bit off topic, I have to say. What are the implications for nitrous oxide as well? There we go.
Okay, can I answer that in 3 ways? So there is my instinct that suggests that potentially there could be a discrepancy there. Then there is what I know. I really need to get in those numbers and look at it. I think the other thing that interests me about nitrous oxide is people get very excited about it because the GWP figure is shown by kilo. If you do it by mole, it's at which chemical reactions are driven by, it's actually the same as methane. So because the molecular weight of nitrous oxide is so much greater than the molecular weight of methane. So I suspect the numbers are higher, but it's no worse than methane on a molecular basis. It is on a kilo basis, but you get far fewer molecules of nitrous oxide per kilo than you do methane. So yeah, I mean, it's something definitely on the agenda, something to have a look at. Methane's been the prime driver to date, but yeah, nitrous oxide could be. And if you're interested in it, let's come have a chat and we can work out how we move that forward.
Okay, great. Thanks. I think we'll draw it to a close there. Thanks very much, Andy. Lots of stimulating food for thought there. And we're going to move on to our third talk, which is David. Thank you, Andy.